I'm very happy to announce the next speaker. It's Johannes Ba. I know already Johannes for a few years. He's a regular speaker at our SBA security meetups. So if you want to hear more of Johannes after this talk, please join our meetup community. The last time Johannes talked was this year, actually, I think in April, if I'm completely correct. And he will present today attacking Kubernetes managed environments. Johannes is team lead and penetration tester at Condignum. Condignum is also a partner of SBA Research and of the sec4dev conference and is also a sponsor in that regard. So if you have other security questions to Johannes after the talk, please engage him in the break. And I would say we can start directly with your talk, Johannes. And please also don't forget to post questions on Slido, and I will also launch a feedback round for the last talk from Lucas. Thank you.
Thank you, Nikki. How many of you had the pleasure, voluntarily or involuntarily, to work with Kubernetes? Can you raise your hands? Oh, a few, okay. More as like developers or DevOps or administrators? Okay, that wasn't really a question, but okay. All right, in this talk we're going to focus on Kubernetes. It's a 30-minute talk, so I have to be like a bit fast here and there. Don't be sad if you don't get all the concepts. Nobody does, actually. So we try to focus on the perspective once an attacker, through whatever vector, is infiltrating or hacking an application that is running in a container. And the question is, you know, when it's running managed by Kubernetes, what's new then? That's my topic. Just a few words about, by the way, am I loud enough? Is it okay? Can you hear me? Okay. About our company, Condignum, we are building a software as a service security platform. It's more like a security self-help platform. So if you're like building something or running an application, managing some kind of software like an Active Directory or something, we got all security stuff covered, so you can sign up there. We're also doing consulting services, classically like pen testing or red teaming, as it's called these days. Yeah, that's what we are doing. Just a few words about me. I'm leading our team. We call it professional services. It's mainly pen testing, red teaming, source code reviews. My Kubernetes security background is a bit more. I think 3 years ago, a few customers asked us because they decided to roll out Kubernetes, and then at some point, questions about security arise, and they asked me if I can, help out a bit, and that's how it started. Yeah. So what I usually did was writing rules, like we come to the topic later for Kubernetes, like pod security policies, role-based access controls for Kubernetes, to make it more or less, to make the things not worse as they already are. And currently I'm more or less doing security research on so-called Kubernetes extensions. They aren't really extensions, they're somehow registered in the API, but besides that, it's just software running on your nodes. The main topics are about, I'm going to give you a quick intro about Kubernetes and its architecture, and then we dive into the security aspects of it. So what's Kubernetes? It is container orchestration. I mean, it's just a word, but just think about it. When you're deploying more than one application in a container, then at some point you might need, okay, how can I manage that? So it stays up, redeploys and everything. This is also a pretty important question at some point. Do I really need that kind of tool? It's usually fun to play around with it until you have to use it, actually. So if you're just having like one application in a container, you probably don't need a Kubernetes cluster or something. It's when you're needing to deploy a lot of applications, a lot of various applications, microservices as they call them these days. And if they have to like interact with each other, then you might have to think about using it, because it's probably the best tool for managing more than one container. Just a few words about containers, because this talk isn't about containers. Kubernetes managed containers, but these are Linux kernel features which help you to approach isolation. Yeah. This usually works through Linux namespaces for PIDs, net, mounts, and so on. Control groups, copy on write file systems. So if you use all these kernel features, you can, by the way, do it on bash in 5-6 lines, and you got a container. Then these processes running in there are more or less isolated from the rest of the processes running on your Linux system. Yeah, that's the main idea. Just continue. There are a few good resources. I try to link up as many good resources down there, so because it's a huge topic. If you feel like, pick up the slides in the end and just read a bit through them. The main idea how Kubernetes works, in a few words, it's pretty challenging. There's this core concept, it's called the Kube API server. Everything in Kubernetes is managed through an API. It's REST-based API. They call it the control plane. All your deployments, all your secrets, all your resources are being stored in there. They're using an ETC database behind that. It's a key value store. It's in memory. It's supposed to be pretty fast. They got a scheduler for scheduling stuff. They got a controller manager to control all the other controllers. Don't ask about it. And they got these so-called kubelets. They are running on every single one of your nodes. Nodes are just hosts. Could be a virtual machine, could be a physical machine, where you're then in the end deploying all your containers. And there's a proxy running on them to, expose your running services, like running web services, which they mostly are. And on every node, there's a container runtime. I think most people heard about them, stuff like Docker or Cryo. These kind of tools, they are being used to like create a container. So it's more or less easy that you don't have like run 10 bash commands to get your container running. A few naming concepts. The most important ones up there are pods. A pod is a name for, it can be one or multiple containers. I would just say, think about it that way right now. There's no need to dig into it any deeper. They're running in the same context. They're sharing the same namespaces on the host, just the same Linux namespaces, which is important. They're also a bit misleading, the Kubernetes namespaces. They're using the same terminology for whatever reason. They are not Linux namespaces. They are really more or less present in their API. You can think about them as virtual clusters. They are dividing the cluster resources into various aspects. Down there are four of the typical namings they're using when you want to deploy an application, because it's not only a pod. Inside of these pods, your application is running, but they're using stuff like replica sets, a deployment, stateful set, and so on. It isn't that important right now, but if you really have to deploy something in it, then you have to pick one of those, which makes sense for your case. This is just a really short introduction about how these container runtimes on the nodes are usually working. In this example, it's Cryo. It could be Docker. Doesn't really matter. In the end, at some point, the Kube API server is talking to the kubelets. The kubelets are talking to your container runtime, and then they are deploying your container. Yeah. This is more or less standardized. They are using OCI standards. So these container descriptions are more or less well formed. But in the end of the day, Cryo, Docker, however they're called, they are preparing your containers for you, and they're also like monitoring the status of a container and just handing it back to Kubernetes so the DevOps people know what's up. This is now that we ran through Kubernetes and the concepts. So what is the attack surface of containers in general? Before we dig into Kubernetes, as I said before, this talk isn't going to be about containers by themselves. It's more about Kubernetes. But just think about before we think about Kubernetes, we have to at least address, the attack surface of a container to just keep it in mind. Container runtimes, they have bugs sometimes. There are a good number of them. This is an attack surface. You can run containers which are overprivileged, which can usually access host namespaces of the Linux system. You can have too much capabilities. There can be file mounts and all this kind of stuff. Sometimes you can access the Docker socket, which is bad. Then you can redeploy or change or alter running containers. And I think in my eyes, most importantly, kernel vulnerabilities. A container is an isolation approach for applications running in user context. At the end of the day, you're using syscalls to interact with the kernel, and that kind of attack surface remains. It can be a bit less if you take away capabilities of your application, but that's a story for itself. But in the end of the day, when you are deploying a container, keep in mind to patch your system. Otherwise, you'll be exposed to privilege escalation bugs in the kernel, just like you would do it if you just run an application, not in a container. Okay. So now we're going to start with Kubernetes by itself and the security aspect. So let's just think about it. You spawn a shell on a container, or the attacker does it. I mean, what's new then? That's the main question, because I mean the attacker doesn't care about Kubernetes. You know, okay, there's a cluster running, and who cares? Yeah, because usually what are attackers doing when they're attacking a Linux server and not a Windows system or Windows server? Usually they want to steal data, so they just maybe like steal your database credentials and just load all the data and leak it or something or sell it. Or if they want to keep it silent and just get a bit further, if they try to break out of a DM set, they try to laterally move through a network. That's the thing that they usually want to do. Yeah, and they also want to, if they want to stay silent, persist themselves. So when you exploit a vulnerability, a known one or an unknown one, then you are on this box. But the point is, this container they're quite often short in life. So when they redeploying the container, then your shell is gone. So this is quite a challenge when you are doing pen tests or red team assessments on containers. You have to somehow laterally move at the same time, or try to abuse some Kubernetes feature to get some persistence in the cluster. But that's like a story for itself. So yeah, what's new then? Yeah. So the point is then the main new attack surface is the Kubernetes API itself. That is a bit counterintuitive, because usually if we think, okay, you'd deploy a container, and it's just the container and your application is running there, and that's about it. And the application is usually exposed through a proxy and so on. But per design, the point is I don't really know why until that day, because I haven't seen a use case where the running container needs access to the API all the time. I've heard about some. My customers usually don't need it, so we just turn it off. So the API is reachable from inside the container. And not only that, there's a service account token, which is mounted by default inside of the pods. These privileges, it is mounted under a Linux path, var run and so on. The privileges vary. Per default, it's the default user of your current namespace. That can be harmless, because you can't just query anything. That would be the best case scenario. The best case scenario would be if the token wouldn't be there at all. But that can be different, and we've seen a good number of use cases where these kind of tokens are pretty highly privileged. And yeah, we're gonna talk about what can happen if your privileges might be way too high on your token. But there are security features in Kubernetes which might help us with securing that. One is called the role-based access control, RBAC. I don't know how to pronounce it in English. This is the main authorization scheme. It gives you the possibility to finally crane access on your API, and it should be used. The thing is, I think these days, I'm not so much aware anymore what's the default deployment configuration, since people deploy Kubernetes from all kinds of sources. The point is you can turn it on or off. If you turn it off, you have no authorization at all, and every user, every service account token is highly privileged, which shouldn't be done. Yeah. The point is, luckily, it's easily possible to not mount it. I think I had an assessment 2 months ago. It was the first time when I've seen it, that a huge Kubernetes deployment, and they were not mounting it explicitly. It was the first time. Usually they are just there, And then you got a new attack surface, which an attacker can at least try to abuse it. So the attack surface of role-based access control. I just try to list the most important ones, which should ring a bell when you see them. Any rule on any resource can be, I don't know, can be secrets, can be pods. Any rule for low privileged users, usually not a good thing. Yeah. Secrets. Kubernetes comes with a secret management tool. Just imagine when you're deploying an application. And you got your source code, you got your repository, maybe you got your pipeline and everything, and they are deploying your stuff in a cluster. Nobody wants to see you putting your secrets in your code. I mean, these days most people know it, but it still happens. That's why there's a secret store in Kubernetes. So during deploy time, you can deploy secrets from the secret store, stored in your namespace, and put them into your container. For example, database credentials or credentials for middleware or something. Yeah, then also privileges on deployment resources, like pods, or the other four different kind of stuff which exist, deployment set, stateful set, and so on. If you have privilege on them, you can do this typical lateral movement towards different containers, just like you would do it in a Windows Active Directory domain. Just like there you're starting low privileged on a Windows client, you try to get more and more and more and more privilege. You can do the same kind of stuff with Kubernetes. Create update bindings on role bindings. That's the core essential of robust access control are roles and role bindings. Roles define a rule, bindings bind rules to a subject. These are a few more of them, you know, create any rules and so on. It's not that important right now. A nice thing for administrators as well as for attackers is that the Kubernetes API got this nice feature for you to list your current privileges. You just take your token. Token is usually JWT token signed by the certificate authority of your cluster. You just take the token, query the API. It's and then you get your current privileges. kubectl, just to describe it shortly, it's a command line tool to manage the cluster. You can do the same kind of stuff using curl or wget. Doesn't really matter in the end. It matters when you're on a container and the base image of the container is minimized. So there are probably, best case, not too many tools. Some web tools are usually there, so you can't just upload kubectl and query it, but you can, the same request which you're using with kubectl, you can do manually. There are some tools to audit your robust access control models. If you are running a container, check them out. It's actually pretty easy to audit them. You know, once they're there, it's pretty hard to audit them on the command line because I don't know. Until the day, I would say Kubernetes didn't really brought a nice way to check out the rules on your robust access control stuff. But they are like tools made by the community. All right, that was in short role-based access control. The second main attack surface is overprivileged pods. So there's a concept. It's just called privileged. These kind of containers, pods, let's stick to that word, they share namespaces with the host. The point is there are some privileged pods needed to, for example, to configure your underlying host. Kubernetes by itself is bringing out some components which, just changing configuration of the underlying host, doing network manipulation, for example, device access. Just think about if you want to have like drivers on your clusters. There are some special need clusters which need, I don't know, graphic card drivers or something. They need higher privileges. The bad thing is if you have a shell on them, then you mostly, more or less, have a shell on the underlying host. Because since they are sharing a namespace, a Linux namespace with the host, you can just like access the namespace of the host. There's a command line tool for that. It's called namespace enter, ns-enter on Linux. You just enter the namespace and then you're like really root on the underlying host. Just keep in mind, it's some more container magic. Root is root on a privileged container is root on the host. But if you're having an unprivileged container, you can still be root in there. Then you're having root rights in this container, but not on the underlying host because you don't share the same host namespace. Yeah. It would be talk for itself to like see how the kernel is making a difference between that, but that's possible. Still not recommended to be root in the container. These are some of the attack surface which you can like configure in your pod definition if you're allowed to. We're gonna see later how we can make people not use it. The host PID, for example, host IPC in the process communication, host volumes access, privilege escalations and so on. Usually, if I would have more time, we would use a demo and just query the API. But can you read that? Oh shit, it's a bit. It's just like what would you do if you had a shell on a container to query the API? There are, let's say, four elements which are available for you on this node. There's the API server. There's a Kubernetes DNS name. It's called kubernetes.default.service. That's the address of your Kubernetes API. So you don't have to port scan the IP range. It is there for you already. You already know where the API server is. So then there's a service account token. You've seen it's var run and so on. Can be somewhere else, because you can change it, but usually it's there. Then you got your namespace, because you need a namespace for inside of your API space on REST API to know where you can query it. And then there's the token itself. So there's also a CA for securely connecting to the API. You can ignore it and insecurely querying the API. It doesn't really matter. Yeah, and then you just go and query the API. In this case, what did I do? I just ask the API if it's available, and then we'll see, and if it works, and so on. So this is one example to, let's just say you leaked a token, and you try to find out what your current privileges are. Just ask the API. In this case, I was using kubectl. It's possible too. Then just like imagine you would maybe find a secret, in there, and just use the secret. Query the API as well. And this is one example how an JWT looks like. You just can. That's how it comes from the API. Then you just use it, and this is one example query to start a privileged container. It looks a bit weird, but what's it doing? In the beginning, it is mounting proc1 is PID1 root namespace mount, and accessing it with bin bash and using that doing a namespace enter. Then when you're running this container and you're privileged, you got a root shell on the container. If you guys feel like I'm around, I can show you hands-on later. These are some nice queries which you can use if you got a token and want to see what's up there. Show all images, get the network policy, show all cluster admins, show all roles, show secrets and so on. Show all the images which are available, all persistent volumes, which pods can mount. Get a list of all the privileged pods, all root pods, and so on. So what's the question is then, what can you do to make users not deploy highly privileged pods? It's pretty simple. There's something called pod security policy that changed now. They deprecated it and called it pod security standards now. Haven't seen anybody migrating it to it yet, but at least none of my customers. What they're doing is they're putting constraints on newly created pods. So if you want to deploy a pod, at some point, the API checks, okay, which pod security policy is it allowed to use? And then it's being checked against it. And if it fails, or it's being mutated. And that effectively can hinder the creation of unprivileged pods. And that should be used. Otherwise, it's going to be tough. Just a comment on pod security policies versus the pod security standard, which is new by now. As I was saying, I haven't seen it in practice on customers' clusters yet. The sad thing is I'm not so convinced that it's that good. It's making the use of pod securities a bit more easy in my eyes. But the thing is, it gives you the chance to deploy a pod security policy which would maximally warn the user that you're doing something dangerous. He can probably know where this is going. Yeah, probably in, I don't know, two of 10 cases, one of 5 cases, it's probably gonna be way too permissive. And the good thing about PSP was when it was working out, it was hard to make it work. But when it was working, it was almost impossible to deploy overprivileged pod when it's there. It also makes it hard to deploy anything at all. Yeah, but in my eyes, it worked. I think their decision to change that was because it wasn't that usable, which is a fair point, I guess. Yeah, and PSPs were also not that, it didn't give you that many options, which it should be. That's why they created new tools like Gatekeeper, which give you way more options to check on images themselves, and so on. Yeah. Yeah. So as I was saying before, this is why I'm a bit skeptical about pod security standards. Is anybody here who is involved in the Kubernetes team themselves or building it? Nobody? Okay. There are 3 policies, which makes it a bit easier. It can be privileged, baseline, or restricted. These are 3 security layers. in the end of the day, they are also pod security policies. But the idea is it makes it easy for users. Just like roll out restricted policies and you're all good. But the thing is, I was saying before, what's dangerous is they can be run in different ways: enforce, audit, and warn. And when you're migrating from an existing working stuff like a pod security policy, there are guides out there by the Kubernetes team, by the Kubernetes cloud teams like by Google or by AWS. They are like, you can enforce it, you can audit it. Audit means it's being logged, and warning means the user gets a warning, and that's about it. My estimation is during transformation of the old to the new standard, people will use warn, audit, and best case scenario, in the end, they're going to change to enforce, but it's a best case scenario, Yeah. There are the most important standards in the pod security policy, which make you not being able to run a privileged container. Yeah. Host PID, host IPC, host network. False means you can't access those namespaces. Yeah, and there's a lot of different ways to harden it even more. You can use read-only file systems. You can deny people to access volumes, and so on. Which is also pretty nice. These are security things which need some more efforts to make them run. Like when you run an application, you can make them drop capabilities. So you have less options to interact with the kernel, which, coming back to my point before, which makes it harder to exploit kernel privilege escalations in case there is one. Yeah, there's different stuff like policy as code solutions, which gives you the chance to fine-grain your security constraints even more. Gatekeeper is a good one for that, but it goes far beyond right now. Another really important topic is network policies. If you don't have any in place, so then your pods will just receive traffic from all over the place, and there's really nothing you can do except maybe your firewall in front of your DMZ, best case. Yeah, and that network policy is a feature by Kubernetes, and that should be used to just reduce the impact of a breach. It's a classical, really old concept of having a firewall. The less kind of services you can see on the network, the lower your chances are to have lateral movement scenarios. These network policies are usually built on some sort of CNI as a container network interface. That's a story for itself. They're using tools like Celio, something. So what's happening at the end of the day is on Linux, they're using techniques like VXLANs or IP and IP tunneling to tunnel cluster traffic between the nodes and the master. That's what it's doing in the end of the day. And on top of these interfaces, they're using IP table rules or eBPF rules, to make it short. Yeah. And these rules are usually then interpreted by the worker nodes and being put into place by SSAing IP table rules. And the point is, if I use properly, then it might look like you have a default ingress-egress. You don't deny everything and just allow selectively. I know it's cheap talk, but in the end of the day, that's what's happening. Yeah. There's also a different tool, probably going a bit too far. They call it a service mesh. It's annoying word. It doesn't make too much sense in my eyes. What they're doing is you deny every kind of network communication on your containers, and you deploy a second container next to your main container. They're calling it a sidecar, like on a motorcycle, next to it. And that's technically just a proxy. And this proxy is allowed to communicate with other proxies on the other pods. And they're using MTLS, like dual-side authentication, using certificates. That ensures authentication, and all your services are not exposed, except for services which are having one of these TLS certificates, which is pretty good, and also, of course, transport encryption. If you manage to get this running, then you're pretty good to go, but it isn't that easy. All right, okay, yeah, 5 minutes, I see, and we're coming to the main takeaways right now. If you have the pleasure to run a Kubernetes cluster, try to use PSPs, pod security policies, so your users are just allowed to run low privilege pods. Yeah, use least privileges, saying role-based access control. If possible, don't mount service account tokens in most cases, just my estimation. You can correct me if I'm wrong. Most cases you don't need API communication from the pod. There are some scenarios, I know, but mostly not. Don't mount volumes if you don't need them. No, it sounds trivial when you talk about it, but it isn't so trivial when we actually have to do it. Use network policies so you can filter. And also pretty important stuff, no deployment on master nodes. Just keep it on separate nodes because, in the end of the day, your attack surface is Kubernetes API and the Linux kernel. And privilege escalations on Linux are still quite common and available here and there. And I've also seen quite often that the underlying nodes of clusters aren't being patched that regularly, So. These are some general recommendations. They are not really, focused on Kubernetes themselves, but they still have to be pronounced. Patch, of course. Yeah. Isolate clusters from the rest of the network. DMZ, no internet connection, and so on, if possible. There are way more cool security features available. Security monitoring IDS. There's a tool called NeuVector that's recently been bought by SUSE, and now it probably costs money. There's sec4dev for syscall restrictions, AppArmor for application whitelisting, SE Linux for mandatory access control. The last three, they come with some effort. Then you really have to monitor your running application and see, okay, which kind of syscalls can I stripe away? But it's probably worth it. Yeah, take care where your container images are coming from. There are some quite okay and legit image registry available, but still, just don't download random images. And the good thing is to minimize them. Minimize meaning only have onboard tools on it which you actually need. Try to use logging and don't just pipe the logging files into the ether, but keep them somewhere where you can 2 weeks later try to see if in case something happens. Last point, really important. I didn't focus on that talk. It's important for security since it's availability. It's resource limiting, and that's one of the main features where when a class is going down, means the pods had too much memory, too much CPU usage, and then they just go down. There's a solution for that. It's called resource limiting. It's available, but you have to use it and calculate it and all kinds of stuff. That's about it. I think it was 30 minutes. But okay, pretty fast. Sorry for the fast talking, but yeah. Try to get it through. Just in the end, short thing, we are hiring pen testers, developers. In case some of you want to change career paths from developers to pen testers or something, give it a try. Thank you.
Perfect, thanks. Thank you, Lucas, very cool. Johannes, sorry. How easy is it to access API server in case of an SSRF attack, and how much access does a pod have by default?
So SSRF is usually more dangerous when your access token is mounted to your HTTP client, which I would say by default on a Kubernetes pod it's not. So the file is mounted, a token on a file system. So in case you have an SSRF on your application, that would mean your request to the API server would be authenticated as it's called unauthorized. You can access some information on the API, but it wouldn't be that dangerous. In my estimation, you would need to get at least a file disclosure on the host or RCE to get the token and then be able to carry that. Otherwise, SSRF is mostly, in my eyes, mostly information disclosure only. Yeah.
So next question up is, why is the API server reachable from every pod by default? Should this not rather be opt-in?
Yeah, I think so too. The point is, I was saying before, I don't know if anybody of you is using Kubernetes, contacting the API from inside of your running containers. Is there somebody? Because my customers, usually nobody has to contact the API server once their thing is running. I think maybe, you can make up some scenarios where your running application needs resources during deployment, and I don't know, some new information. You can use the API for that. That's probably about it. I don't know.
which of the presented recommendations are still relevant when you're using managed Kubernetes on a cloud platform like AWS?
I would say all of them. I mean, when you're using AWS or the Google platform, you still have to use role-based access control. You still have to isolate your API. You still have to run underprivileged pods whenever possible. The only thing which is not so relevant is the isolation of the cluster components from the rest of the network, because these managed Kubernetes environments, as far as I know, they usually isolate the API server from the external network. But on the internal network, it's probably the same, I guess. Not 100% sure.
Okay. And is there a way to audit a Kubernetes cluster for misconfiguration or vulnerabilities?
Yeah, there are a lot. If you like down on my slides later, there's a lot of stuff coming in here, which give you the chance to, and then there's lots of tools listed. The probably most well-known is Syscan, a Center for Internet Security. You can use that. There's Kube Audit, Kube Bench. There's a good number of tools because it's easily auditable since it's just like an open API. I just keep it open. There's this one here. Yeah, there are a lot of tools. So I was saying because a REST API makes it easy to audit it. Since everything is a resource, you can just query it. And yeah, the Kubescan is pretty good in my house. Down there, RBAC audit to get like the effective rules which you have in. Yeah, there are a lot of tools for that actually.
Which is your favorite, or which combination do you use most of the time?
I would say for auditing role-based access control, it's the last one. It's just like a pretty simple Python script. I'm usually auditing manual, so it's that one. Which is also good is Kubebench. This is a CIS, as I was saying before, Center of Internet Security. They are bringing out hardening guides for all kinds of stuff. And if you want to know like the basic security configuration of your cluster, because you can misconfigure them pretty badly, you can use that one, and they're going to check if all the security settings are configured for your API services. So I would say RBAC audit and Kubebench overall.
Perfect, thank you very much. What was the biggest Kubernetes cluster you have seen so far?
We got one customer, I think they are running 400 nodes, 400 hosts, each of them at least 46 gigabyte of RAM. And they are, I mean, it's not only 5% there, I think 50% commitment on it. Yeah, that's a lot. Yeah, and the point is they usually, when you're having, it's even getting more complex, you don't have to like, they are then usually having 40 Kubernetes clusters managed by a cluster management framework. I know it's annoying. There's, for example, there's Rancher. It's an open source tool. The tool is designed to manage lots of clusters. And Rancher by itself is a Kubernetes cluster as well. Yeah.
And there's one more tip asked, is which managed Kubernetes environment has the best secure by default configuration?
Good question. Good question. I wasn't, I would say the AWS Kubernetes configuration isn't that bad by default. Yeah. I'm also saying, I started 3 years ago. 3 years ago, the default configuration was a catastrophe. These days, if you deploy a container, it isn't that bad anymore. There's pod policies available. Robust access control is usually turned on by default. The kubelet and kube AP server, they're having all dangerous kind of configurations striped away. I was saying in the cloud, probably AWS. And just like to summarize it up, default configuration is getting better, even on-premise. Yeah.
Oh, that's good to see. That's nice. So, warm applause for Johannes for his talk. Thank you very much.